Today we're going to talk about two things. The first thing we're going to talk about is unknowns or variables. The second thing we're going to talk about is the distributive property. So let's talk about unknowns or variables. Let's say in some dream world, well, first I guess I should say some of you have met my dog, Sunny. And let's say somehow I have two Sunnies. So let's get Sunny on here. Boom. So I would say that I had, if I can do this, I would say that I had two Sunnies. And my wife comes in and she says, "You'll never guess what just happened. I just found 3 more Sunnies." Okay, well then, how many Sunnies would I have? I'd have 2 Sunnies plus the 3 Sunnies, and total, that would mean that I'm left with 5 Sunnies. If I can, sometimes these are tricky to grab. 5 Sunnies. And this is a really good way for us to think about unknowns or variables, right? I wouldn't say, well, let's just maybe turn this into a math thing. So Sunny, if I can. So I'd have 2 Sunnies, or S. What if I said S was for Sunny? And I had 3 more Sunnies. Well, that would be, again, 5 Sunny, right? 2S plus 3S is 5S. And maybe even more if we want to go more algebra. That would be like 2x plus 3x equals 5x. So these X's or these S's or these Sunnies all just stand for some unknown quantity, right? Something that we don't know. We don't know the value of it. And even as we get later on in the course, that value could change. So we need to keep it as an unknown, as something that could change. That's why we use letters. Even, the Greeks, they had their own kind of numbering system. So maybe sometimes you'll see, I don't know, can we do this? Maybe sometimes you'll see something like 2 delta plus 3 delta equals 5 delta, right? The kind of the crazy things. Anything could go there. But the point is that it represents a number that isn't fixed, that we're either not sure of yet, or that we are not defining because it could change. Okay, so that's kind of this idea of variables and unknowns. And let me throw something in front of you here. Right, these Sunnies are all the same. But, and I'm going to try my best. If someone came in and they said, "Oh, I have Sunny's favorite snack. I have 3 slices of cheese." So maybe we could do 3. I have 3 slices of cheese. Oh, that wouldn't be good. I have 3 slices of cheese. Right? And I guess we can add there. Okay. And so maybe our neighbor came in, and then our other neighbors came in and they said, "Well, I have 3 more, or I have 6 more slices of cheese." Right? Well, you wouldn't just say 3 plus 2 is 5 Sunnies and cheese, right? That's not how we think about things, right? At the end of the day, if I had 3 slices of cheese, 2 Sunnies, 3 more Sunnies, and 6 more slices of cheese, at the end of the day, I would have 5 Sunnies and 3 plus 6 is 9 slices of cheese, right? So when two things are different, then we have to be careful, right? We don't combine them unless they're the same thing. How would that look for algebra? Well, let's say here I have 2x and 3x. Maybe we can rectify this a little bit so it's just easier to see. Oops, sorry about that. What if we just do this? Okay, just real quick to make sure we fix this. 2x plus 3x equals 5x. Okay, and now we can, oh, well, what if I said I had, let's say cheese is y. So what if I had 3y plus 2x plus 3x plus 6y? Again, we can't just add 3 and 2 and 3 and 6 because those aren't the same thing, right? They're different. So I combine the 3y and the 6y, and I also combine the 2x and the 3x, leaving me with 5x plus 9y. Okay, so that's unknowns. Now, what about distribution? The distributive property. I'm going to put this in front of you. What if I had, we'll say 2 times 5x plus 7. Okay, well, what I'm really saying here, just like earlier, right? I'm going to scroll up. I had 2 sunnies. Here, I have 2 5x plus 7. So that's like saying, this is like saying 5x plus 7 plus another 5x plus 7. Or another way that you might think about this, okay, so I have 2 5x's. I could write that as 2 times 5x. Let's make that parenthesis. Let's make that orange. 5x. Oops. And I have 2 7s. So that would be plus 2 times 7. Now you might be saying, oh, I know this. This is the distributive property, right? Where I take the 2 and I multiply it to the 5. And I take the 2 and I multiply it to the 7. Yes, you're exactly right. That is the same thing. So if you thought that, then yeah, you already knew it, right? So my final answer then would be 10x plus 14, right? 2 times 5x is 10x, and 2 times 7 is 14. Okay, I'm going to ramp it up just a notch for one last example for this video. Let's say we had something like 2 times 6y plus 5 minus 3 times y minus 7. I don't know. Okay, what would we do in this situation? Well, the same idea, right? Here, we could write it out like this. We could write out our 2 6y plus 5s, but we get into trouble here when we subtract the 3y minus 7. So let's be really careful here. Yes, 2 times 6y minus 5 is, maybe there's some way I'll write this in orange to make it stand out. So 2 times 6y is 12y. 2 times 5 is 10. Okay, now we have this tricky part here. It's minus 3. So I always, every year, have students who will just distribute the 3. But because it's minus 3, you need to distribute the whole term, the whole thing, minus 3. So minus 3 times y, maybe I can use a different color. Okay, so minus 3 times y and minus 3 times minus 7 would be minus 3y, and negative 3 times negative 7 is plus 21. And then this is just like our problem above with the sunnies, right? I have 12y and negative 3y, so I need to combine those into 9y. And then I have plus 10 plus 21, so I combine those into plus 31. So when you distribute, make sure that you carry those negative terms, but also make sure that you're only combining the like ones, right? If it doesn't have a y, so we call this, if I have something, if I have 12y, right? We combine this is called a coefficient. So that's a coefficient. Oops, I don't need another E there. Which is a big scary word that just means how many of them we have, right? So I have 12 y's. And then this right here, that is the unknown or the variable. So hopefully that brings it back full circle for you and helps you get a grasp of not only unknowns and variables, but also how to use the distributive property.